Alright, on the last day of infinite limits, we're going to look at some application problems. So, in this first problem, this is a longer problem. It says, on a trip of D miles to another city, a truck driver's average speed was X miles per hour. On the return trip, the average speed was Y miles per hour. So you have this truck that drives this direction, X miles per hour, and then he drives back Y miles per hour. Average. The average speed for the round trip was 50 miles per hour. I'm supposed to verify that this is true. So what I've got to do is I'm first going to start with just talking about this in general. The average speed, okay, is equal to the total distance over the total time. And how did I know that? Well, that's going back to the formula D equals R times T. So if you just solve for R, you get D over T. So total distance over total time. It tells me my average speed overall is 50. So I'm going to plug in 50. My total distance, they say, on a trip of D miles. Well, I'm going there and back, so my total distance is actually 2D. And then my total time is the distance divided by my rate plus the distance divided by my rate. Because time is distance over rate. So I have this new equation. Now what I want to do is go ahead and simplify this. I'm going to change colors. I can actually take out a D out of each one of these. So I've got 2D over D, 1 over X plus 1 over Y. And so my D's cancel. Then what I can do is make a common denominator and be able to add those two fractions together. So I'm going to have XY be my common denominator, so that means I have Y plus I have X here on top. Now what I'm going to do is go ahead and put those together, and I'll come up here to do that. So now I have 50 equals 2 over, it'd be Y plus X over XY. Now I'll go ahead and divide those. So now I have 50 equals 2 over 1 times the reciprocal XY over Y plus X. Now I have 50 equals 2XY over X plus Y. Now I can get rid of the fraction by cross multiplying. So I get 50x plus 50y equals 2xy. And what I'm trying to do is get y by itself. So in order to do that, I need to put all my y's on one side. So I'll move this y to the other side. So now I've got 50x equals 2xy minus 50y. I'm going to factor out my y's. So I have y times 2x minus 50. And I'll come up here to finish. Divide. So I have 50x divided by 2x minus 50 equals y. And I almost have it. All I need to do is I'm going to then take out a 2 out of the top and a 2 out of the bottom. And then those 2's will cancel. And now I verified that this is the case. Okay, and then the next part of this that they want me to do is they want me to fill out this chart. Now I'm just going to go ahead and fill it in for you. The way I'm doing that is just by plugging in those numbers. So when you plug in 30 in for this function, you'll get 150. When you plug in 40, you get 66.6 repeating. Plug in 50, you get 50. And plug in 60, you get 42.857. So the question says, find the limit of y as x approaches 25 from the right. So as we're getting closer and closer to 25, okay, because If I'm moving this direction, I am getting closer and closer to 25. What's happening in my numbers? Well, they keep getting bigger and bigger and bigger. So therefore, the limit as x approaches 25 from the right of my function, 25x over x minus 25, it equals infinity. This is the last problem that we will be working on together in this section, and it says consider the shaded region outside the sector of a circle. So this is supposed to be looking like a circle here, and then this is the sector area. It says that we have a radius of 10 on our circle, and then we have the inside is a right triangle. So in order to write this area, what we're going to do is we're going to find the area of the whole triangle first, which would be 1/2 base times height. Then what we're going to do is subtract off the area of the sector, which would be this right here. This sector, this part of the circle, the formula for that is 1/2 r squared, the angle measurement. X is the angle measurement. Now, once I find the area of the triangle and then I subtract off this sector, I will be left with the blue region, which is what I'm looking for. So what I'm going to go ahead and do is start to fill in this with actual numbers. So my base of my triangle is length 10. The height of the triangle, I don't know right now, so I'm going to have to figure it out in some way, shape, or form. So I'll label this as H right now, and then I'll use some trig identities to help me figure this out. I have opposite and adjacent, so that would be the tangent. The tangent of x is equal to opposite over adjacent, so that means the height of this is 10 tangent x. So we'll go ahead and write that here. 10 tangent x minus 1/2, the radius is still 10, squared x. So that means that my area of x can be simplified into being 50, 100 divided by 2, tangent of x minus, let's see, this would be 100 divided by 2, 50x. Now, using this formula, we can go ahead and fill up this chart. Now, I'm not going to plug each one of these into a calculator and show you guys how to do that, but I will tell you what you get on those numbers after you plug them in. So I'm just copying down from my chart after I've already put them in my calculator. Again, make sure that you are getting these numbers. Try a few on your calculator to make sure that you and I are agreeing. If you are not getting those on your calculator, that's something that you need to bring up during class so that we can discuss it together. The last thing we're going to do is find the limit as a approaches pi over 2 from the left. Remember, pi over 2 is approximately 1.57, so we're looking at this chart, and from the left, what's happening? These numbers are getting bigger and bigger and bigger, so the limit is going to be infinity.